Hello students, this is Dr. D and today we are going to talk about spermatogenesis. So what is spermatogenesis? It is the generation of what? Sperms. Okay. So we are going to start off with the stem cell, the spermatogonial cell. The spermatogonial cell are just above the basement membrane of the convoluted seminiferous tubules. We talked about that in the last presentation. Yes, so remember the testes have these very fine coiled tubules, and if you cut them, these tubules, you will see that these spermatogonial cells are going to be lining the seminiferous tubules. Okay, now the spermatogonial cells are going to divide and they are going to produce the first cell, which is called the primary spermatocyte. So the spermatogonial cell is a stem cell, is going to produce many primary spermatocytes which are going to be diploid. Diploid means two sets of chromosomes. Even before we begin, you need to have an overview of meiosis, which basically is spermatogenesis. So meiosis, you start out with a single mother cell which is going to be diploid. What's diploid? Diploid means having two sets of chromosomes. So then what happens is it undergoes the first meiotic division or meiosis 1, and the mother cell divides and forms two daughter cells. Now the daughter cells are going to have only one set of chromosome and are called haploid. Okay, the haploid cell are called secondary cells. Secondary cells. So you start out with a primary cell, secondary cell. The secondary cell in turn are going to again divide, and so you are going to end up, so each secondary cell divides into two daughter cells. So all in all you will have what? 4 final daughter cells, and each of them are going to be haploid. So basically meiosis, which is a special type of a nuclear division, and spermatogenesis is a type of meiosis, right? So meiosis, when you start out with one diploid cell, you will end up with 4 haploid daughter cells. Got it? So here, like we said, spermatogonial, which is a stem cell, produces many primary spermatocytes, diploid. The primary spermatocyte undergoes meiosis 1, all right, and forms secondary spermatocyte. The secondary spermatocyte are going to be always haploid. Keep this in mind. Use this mantra in your head. The minute I say secondary spermatocyte, secondary oocyte, immediately you should know it is haploid. Got it? The haploid secondary spermatocyte is undergoing meiosis 2 and produce the spermatid. It's not mature sperm. The spermatid will mature and finally form the sperm cell. All right. So here we are seeing the same thing. Primary spermatocyte. It has 46 chromosomes. That means 23 pairs of chromosomes. So 23 pairs means what? So if there's a chromosome A from the father, then there's a chromosome A also from the mother. So this is from the father, this is from the mother. Do you understand pairs? This is chromosome A. I'm just naming it for the sake of naming it. It's not A or B or C or D, but just to help you understand. So every chromosome that comes from your father, the same comes from your mother. All right. So we have 46 chromosomes, 23 pairs. So here starts meiosis 1, and you end up with what? Secondary spermatocyte, and you notice what's happened to the number of chromosomes. It's halved. So we started off with diploid, and now we have what? Haploid in the secondary spermatocyte. Second meiotic division, end up with what? Spermatids. And all of them are haploid. N, 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 and N. They are immature. That's why they're called spermatid. and then they will form the sperm cell. So the sperm cell is going to be very different from the predecessor. All right. So here what do you see? That you have a head, and the head has a acrosome. The word acrosome comes from the word acrid, not good. So it's a fluid-filled cavity, and it lies just above the nucleus. So it's a big head. The acrosome contains higher leuronidase or higher luronic acid. Both are correct. This enzyme will allow penetration to reach the egg cell. All right. There's a midpiece which contains lots and lots of mitochondria. The minute you hear the word mitochondria, remember you're talking about ATP generation. All right, ATP, which is the energy currency of the cell. The tail tail is nothing but a flagella or the flagellum. So here, the minute I talk about flagellum, obviously it means that the sperm is going to be swimming. And what do you need for swimming? You need ATP. Yes? All right, this is important. These are the hormones. So at the onset of puberty, hypothalamus, remember where the hypothalamus is. Hypothalamus lies just below the thalamus. So every information is reaching the cerebrum is going to pass through the hypothalamus. All right. So puberty, you are becoming aware of the opposite sex, opposite gender. The hypothalamus produces the gonadotropin releasing hormone, which stimulates the primary pituitary to produce the follicle stimulating hormone, luteinizing hormone. Follicle stimulating hormone will automatically act on the sustinacular cells. Where are the sustinacular cells? The sustinacular cells are right in between the spermatogonial cell. Between the spermatogonial cell or the primary spermatocyte are these supportive cells called the Sertoli cells or the sustinacular cells. The sustinacular cells are going to stimulate spermatogonia to undergo spermatogenesis. All right. Now here, what does the LH do? The LH or the luteinizing hormone acts on the interstitial cells. Where are the interstitial cells? In between the seminiferous tubules are these cells which are called the interstitial cells or the cells of Leydig. And the luteinizing hormone acts or stimulates these cells to produce what? Testosterone, the androgen, the main male hormone. Now, one thing else or something else, the sustinacular cells also produce inhibin. Okay. So beautiful Mother Nature is. So here, if you have excessive follicle stimulating hormone, you are going to produce lots and lots of what? Sperms, right? But do you really want to be just a sperm producing machine? No, there's an upper limit. You have something so beautiful. All of us have, and that's called homeostasis. So immediately, as it is producing the sperms, the sustinacular cells is also producing another hormone called the what? Inhibin. All right. And the testosterone is there too. What is testosterone doing? We'll see that in the next slide. But basically, testosterone is increasing what? Libido. All right. Now here, you are going to, the inhibin and the testosterone are going to have a negative feedback. They are going to, so if there's very high amount of inhibin and there's high amount of testosterone, they are going to inhibit both the pituitary and the hypothalamus from generating more GnRH and FSH and LH. They're going to say stop. So when you have low sperm production or low testosterone, the GnRH is going to stimulate the pituitary glands to produce more and more of FSH and LH. LH is going to stimulate the production of what? Testosterone. FSH is going to stimulate the production of sperms. But when there is an upper limit, then immediately or excess amount of androgens and inhibin produced in the testes by the Sertoli cells, they are going to have a negative feedback and inhibit excess production of FSH and LH, and therefore the level of the sperms as well as the testosterone will level off. All right, this is the homeostasis. So beautiful. The male hormone, sex hormone, is the androgens, all right, and which are produced by the interstitial cells. Testosterone is a very important type of androgen. Now, some amount of testosterone is produced during the fetal development. You're looking at me and saying, are you crazy? No, I'm not. And why is this necessary? This is necessary, don't forget, for the descent of the testes. All right. Now, one thing that you need to know is androgen is produced by the testes, yes, but don't forget that it's also produced by the adrenal cortex. And keep in mind which layer of adrenal cortex, because adrenal cortex, there are 3 layers, right? Do you remember? Zona what? Glomerulosa, zona fasciculata, and zona reticularis. It is the innermost layer of the zona cortex, which is called the zona reticularis. I'm just going to write the acronym here, but you need to know it. Will produce the androgen, which will allow the descent of the testes before birth into the scrotal sac. All right. Now, of course, during the puberty, you are going to have huge amount of testosterone. What's the effect? Well, of course, it's going to stimulate the formation of the male reproductive organ during the fetal production and the descent. Don't forget the descent part. Enlargement of the testes and accessory organs at puberty, and secondary sexual characteristics. Growth of the body hair, enlargement of the larynx and the deepening of the voice, thickening of the skin, bulking of the muscles, bones, shoulders and the hips, and don't forget, it will always increase libido. All right. So, extremely beautiful play of hormones. Follicle stimulating hormone will stimulate formation of sperms. But what's the use of sperms if you don't have any urge or drive? And of course, that's why the luteinizing hormone, which is always produced in conjunction along with follicle stimulating hormone, will stimulate the interstitial cells to produce what? Testosterone. So you have the sperm cell and you have the libido thanks to the testosterone. And that will ensure procreation. All right. So having said this, I come to the end of this presentation. More to follow next. Thank you for your time and attention. And if there are questions or concerns, please come and see me. Reach out to me. You have a good day. Thank you.